So hello everyone, myself Sushant and with me is Asif. So we are from the SODA team. So in this session, we are going to show a quick demonstration of some of the key features we already have in SODA. So some features and some of these topics we have already discussed in our earlier sessions. So first one is the recent one first, that is Delphine heterogeneous storage monitoring. So this information we have seen couple of minutes back by Naju. So this project is about mainly about the monitoring aspect of heterogeneous storages and also the alerting. So if you look into this diagram, some of the key aspect we have here is one is the support of multiple drivers to handle the heterogeneous backends, and another one is about the output data, that is about exporting the collected information to available third-party systems. And the key aspect here is the scalability, because we will be keep adding the components or the support at both south and the north side. So we'll have a quick demo of the features we already have as part of Delphine. Okay, so as you know, when we want to monitor any of the system, the first thing we want is about the information of the system or some of the access attributes through which we can connect to the system. So Delphine has a registration process, so through which we register the backends. So the backends might have a different accessibility mechanisms such as REST or SSH. So these are the mechanisms which we currently have, and we might keep adding the support for different access mechanism as and when we go on adding the backends. So once we add the backends, that means we are telling Delphine like these are the backends we want to monitor or get the alert information from. So after registering, the Delphine will help to get some key resource information from those backends. The informations such as the volumes available, pools available. So these are the informations Delphine will start getting. So it will, as and when you add, it will start syncing the information, and the synced information you can see here, like volumes and pools are the information which are currently there. And along with, we can also see the details of that. And at any point of time you want to get the updated information related to these attributes, we can always trigger sync storage so that we'll get up-to-date information at your client end. And this is the kind of overall summary page for a particular for all the storages. So right side you can see active alert page. So as and when you get the alert, so you will keep seeing the alert details here. And hello.
Yes, Sushant, please continue.
Yes,
Yeah, okay. So these are the details of the storages. So we also have a state here called sync. That means the earlier sync has been successfully done, and we have the up-to-date information as of now. So when you trigger a sync, yeah, so we have already synced the information. So this is the storage details, what we see for all the registered storages. And on some of the actions available on each of the storage, as you see, the backend information might change for a storage. So we have the option to update the access information so that we'll be able to reconnect. And we also have a option to register the alert sources so that we will be able to get the real-time alert from the device. So these are the key things we have. And this is how we register alert source. We support SNMP v2 and v3 configurations, so user can provide and enable his device for the SNMP trap receiver. So that's pretty much from Delphine side what we have currently, and we also have something called metric collection. So you can see like we also have something called capacity collection, where we can see used capacities with respect to array and free available, all this information which can help the administrator. So this is all about the Delphine. And next up, we have another use case, which is about multi-cloud. So Ashit had already mentioned about this project earlier. So the cloud services and the cross-cloud operations, these are some of the key things that are discussed over a period of time now. So some of the key aspects which our project tries to tackle are freedom to choose most efficient data collection, and enable different policies for the data mobility, hybrid data management, and the unified API for any of the multi-cloud operations. So we have a small demo related to data migration feature. So I'm going to show the quick demo of. So we have, through SODA dashboard, we create a bucket. So for the migration in this demo, we have a source end and we have the destination end, and we set up source and destination and finally trigger the migration. So we create a bucket at source end by selecting AWS as the backend type. And we also have a feature in progress and about enabling the encryption. So we have the bucket at source end now. So we have uploaded an object. So at the source, we are ready with the object, and similar operation we'll be doing at the destination end or the target end. So we have a target backend as Azure, and we select and we create the bucket. Now we go back and trigger the migration for the source object. So we create a migration plan. So you can see like it can be done immediately or you can schedule a time. And also the option is to delete the source object if the migration is completed. So if you want to do that, you can enable that as well. And it is a migration task in progress. You can see the progress and succeeded. So now if we go back and see at the destination, that is Azure bucket, we have a my object which has been migrated. So this is one of the feature, that is data migrate case.
Okay, thanks, Sushant.
Yeah, so if I stop sharing.
Yes. Okay. Hello, everyone. My name is Asif, and today I will give a demo of SODA CSI solutions based on Kubernetes, which were a part of Greenland release. So first of all, why Kubernetes matters to us. As we know that most of the applications are moving to containerization world, and Kubernetes becomes an obvious choice when moving to cloud because of its fault-tolerant nature and self-healing design and so on. So the point is, if the app moves to Kubernetes, then data which is with apps also needs to move along with it. And there are challenges when we manage the data on Kubernetes. So we can see that security, when we handle data on Kubernetes using multiple CSI, then we have different CSI controllers. And the point is that if we try to switch between one storage vendors to another storage vendor, then we need to do a configuration change. And as a user or an admin, it's very difficult to switch between different storage vendors. So storage, so SODA addresses these challenges, and it makes sure that with a unified way, it can switch between different vendors. So we have a unified CSI plugin from SODA. So if a user wants to create a storage, then it creates a PVC. And PVCs are based on storage classes. And these storage classes takes SODA profile ID as an input. And once SODA CSI plugin receives this object, PVC object, for the creation or provisioning of the storage, then CSI plugin forwards this request to SODA API server. And then the call vertically goes down, and the controller and dock dynamically decides which driver needs to be selected for provisioning based on the profile ID. So the point here is like when a user is creating a PVC object, it doesn't need to care which driver will be allocated or which driver will be used for provisioning. So everything is dynamically decided by the controller and dock based on the pool list. So I will directly switch to our demo video. So here we have a Kubernetes environment in which our CSI plugin is installed. So here you can see the list of pods which are installed, and we have offerings for block and file. So to provision any of these storages, first we need to get the profile list from OSDR, from SODA. So once we get this profile ID, we copy this profile ID and we put this as an input in the storage class. So this is where we attach the profile ID in the storage class. And that's all we need to provide while provisioning the storage. So once we put the profile ID, and then we just normally create the pod or the app. So once it's done, the storage class is created, and the persistent volume PVC object is created, and the pod is created. So if we get the pod list, we can see NGINX block is created. So now the NGINX block is running, and therefore the pod has been created and the volume has been attached to this pod. So we can see that PV object, persistent volume object, has been created and it has been bound successfully. And we also have a successful PVC object here. So, and if you get the storage class, we have the OpenSDS CSI storage class available. And if we do an OSDSCTL volume list, we get the volume which has been created and attached to the pod. Here we can see that the volume has been created and it's on the same host. And if we get inside the pod and see whether this volume has been mounted, then we can just execute this command. And here we can see that successfully the same volume has been mounted onto our pod. So this way we can easily use SODA for attaching or for provisioning the storage on Kubernetes, and this way we can dynamically choose the heterogeneous solutions. So that's all from my side. If you have any questions related to this, you can reach out to us on Slack or GitHub. Thanks everyone.
Hey, thanks, Asif. Thanks, Sushant. So let's quickly move. Yeah. So thanks, everyone. So these are the very important use cases that we have demoed, and that gives ample opportunity for different projects also to collaborate with the framework that is there for the SODA. Yeah. Anvit,
right,
over to you.
Thank you so much, Ashit. I believe you can mute your mic. There is some feedback over there.
Okay.
Thank you, Ashit, Naju, Noel, Saurabh, Sushant, and Asif. That was indeed a very informative session on the SODA Foundation projects and the current release that we have, the Greenland release demo.